Right, welcome again grade 11s, and today we're looking at the second part of the revision, which was the quantitative analysis, the percentage composition, and later on we will do empirical formula and adding on to that the molecular formula. That is something new that you have not done last year. So when we look at percentage composition, first of all, the percentage composition of a compound is expressed the mass of each element in the compound as a percentage of the total mass. So the mass of the compound as the total mass of the compound. Just think about it, it's exactly the same as you receiving a test back and you want to calculate what your percentage. You take what you get or got and divide it by what you were supposed to get and multiply it by 100, and voila, you've got your percentage for the test. Now this works exactly the same. So what do I need? I need the mass of the compound first of all, then I need the mass of the element, and then I calculate the percentage. Now to calculate the percentage, I basically multiply by 100. Right, and what am I going to multiply by 100? I'm going to calculate the mass of the element and the mass of the compound, and that I'm going to multiply by 100. So let's quickly run through the few examples. I've added one, so please just look at your notes in order to see what the one is that I've added. So calculate the percentage position of KCl. K, potassium, Cl, chloride. So this is potassium chloride. So I'm starting off by calculating the molar mass of potassium chloride. Potassium, if I use my periodic table, is 39, chloride 35,5. So 39 plus 35,5. We calculate and we find that that gives us a molar mass of 74,5 grams per mole. Right, so let's first look at what is the percentage of the potassium. So for my potassium, I take the mass of potassium. Now potassium has a mass of 39. The total mass is 74,5. I multiply that by 100 and I get a value of 52.35%. So that is the percentage of carbon. Now I can either get the chloride by saying 100 minus that will give me the percentage of chloride, or I can also go and work it out, percentage of chloride in the compound is going to be equal to the mass of the chloride divided by the compound mass times 100. And that works out to be 47.65%. So straightforward, percentage of potassium 52.35 and the chloride 47.65. Right, let's do number 2. Number 2, name. NH4 is ammonium, NO3 is nitrate, so this is ammonium nitrate. I start off by calculating the molar mass of ammonium nitrate. Nitrogen has a molar mass of 14, plus there's 4 hydrogens, each with a mass of 1. There's another nitrogen of 14, and then there's 3 oxygens, which has a mass of 16. Doing the calculation brings me to 80 grams per mole. Right. Now when I go and do the percentage of nitrogen, I have to make sure that I see there's not 1 but 2 moles of nitrogen in this compound. So this one has a mass of 14, that one has a mass of 14, so therefore the total mass of nitrogen in this compound is 28. So 28 grams of 1 mole of ammonium nitrate is nitrogen, divided by the total mass times 100. And typing that into my calculator, I find that the percentage of nitrogen is 35%. The percentage of hydrogen, so we have the mass of the element. Be very careful there in this place. We know that nitrogen, hydrogen, and oxygen is diatomic, but in this section of the work, that has nothing to do with the whole compound. In this compound, the ratio is 2 nitrogens, 4 hydrogens, and 3 oxygens. So the mass of that 4 hydrogens is 4 grams. That is making up the parts of hydrogen in the 80 grams of ammonium nitrate. Times that by 100, and the percentage that we calculate then, 5%. So 35 plus 5 is 40%. In other words, the oxygen is going to work out to 60%. Let's see if that is true. So my percentage of oxygen is, there's 3 oxygens in here, 3 times the mass of 1 oxygen, 16 divided by 80 times 100. So 36 over 3 times 16 over 80. And guess what? We get exactly 60%. Right. So that is my percentage composition of ammonium nitrate. The third one in this problem is CaH2PO4. Right. Now, what is the name of this compound? So Ca is calcium, H2PO4, hydrogen phosphate. So this is calcium hydrogen phosphate. What's the first step always? Calculate the molar mass of this compound. So the molar mass of my calcium hydrogen phosphate is, now there's just one calcium, and that calcium has a mass of 40 plus. Now that too implies that this is twice, we find that part of the polyatomic ion twice in the compound, so I'm going to have a 2 in front of, and then hydrogen, which is 1, so 2 times 1, plus phosphorus. Phosphorus have a mass of 31 on the periodic table, plus oxygen, which is 16, but there's 4 of it, so 4 times 16. So all of that is going to be multiplied by 2, and this works out then to be 234 grams per mole. Right, so my percentage of calcium is, the calcium was 40 of the 234, multiply that by 100, and the percentage that we get for the calcium, 17.09%. My percentage of hydrogen, I do hydrogen next because that's the next compound, is, now there's 2 within, so 2 times 2 is 4, the mass of 1 hydrogen 1 over the 234 times 100, so that's a very small percentage, only 1.71% of my compound is made up of hydrogen. My phosphorus, there's 2 phosphorus atoms in the molecule, so I'm going to have 2 times the mass of the phosphorus, 31, over the total mass times 100, and that works out to be 26.5%. And then finally my oxygen, now same as last time, I can say, okay, all of these must add up to 100, so I can say 100 minus that, minus that, minus that, and I should get my answer. Or if I just calculate it, percentage of oxygen, oops, that's should be a O, not a theta. How many oxygens? 4 times 2 makes it 8. Times 16 over 234 times 100. So that gives me 54.70%. Now, once you go and add this, you have to go and test yourself at the end. Does this add up to 100? And yes, it does. So therefore we know that we're on the right path. Right, so looking at my added question, in this case, I made sure that I only take one of the compounds. So calculate the percentage sulfur in, and you must see we've done this one before. We've done the calculation for this in our first section of work, so we can just refer back to that to get our molar mass. So my percentage of sulfur, so what's step 1? Get the molar mass of the whole compound. So it is the whole CuSO4 with the water of crystallization, and we have that it is, right now we can just go back and go find, where was that? Oh, there we have it, done before, 249,5 gram per mole. Right. Now, I'm only interested in the percentage of sulfur. So I'm not going to calculate everything because then I'm not answering the question. I'm just focusing on the sulfur. Now, what is the mass of the sulfur in this whole compound? It is only 32 because there's only one sulfur atom in the whole molecule. And 32 divided then by 249,5, multiply that by 100 to get it as a percentage. And now we need the calculator. And on the calculator, 32 divided by 249,5 equals times 100 equals. And we get 12,82%. Right. So please do not answer other things when they ask you for a specific one. They are sulfur, so you only give the answer for sulfur. Right, so that is my percentage composition. Next, we have the empirical formula. Right, now what is an empirical formula? It indicates the simplest ratio of an atom in a molecule or a compound. Right, so that is also a definition that you have to know, that what is an empirical formula, and we know that it is the simplest ratio. Okay, now the steps that we follow. Assume a 100-gram sample. Now you're going to use this step if they give you percentages, right? If they give you masses, you don't do the step. But this you always have to go and write down before you do the problems. Then you determine the number of moles for each element. Now if they have mass, how do you get moles? You have number of moles is mass over molar mass. Right, so we're going to use that formula. Then we write it as a ratio, and always use the same ratio as which they've given it to you. Right, and then simplify the ratio, and once simplify the ratio by dividing by the smallest. Divide by smallest. Right, and then we can write our formula. Right, we have two examples in this case. Our first one is we give you 82,4% of nitrogen and 17,6% of hydrogen. It's percentages. So my first thing I have to do is assume a 100-gram sample. Right. Now if I have 100 gram, 82,4 grams of that sample is going to be nitrogen, and 17,6 grams of it is going to be hydrogen. Right, so when we go and write this down, we can say we therefore have 82,4 grams of nitrogen and 17,6 grams of hydrogen. What's my next step? The next step said, determine the number of moles of each element. Right, again, it's elements. Do not confuse with diatomic. We know both of these are diatomic elements, but in this case, when they form a compound, they don't have that behavior. They don't behave as a diatomic molecule anymore. Right, so we're going to use our formula. Number of moles is mass over molar mass. and this is for the nitrogen. So I use my 82,4 and I divide it by the molar mass of nitrogen, and that is 14. So we get a value of 5,88 mole. Do the same for the hydrogen, and please always go and write down your formula. 17,6 divided by the molar mass of hydrogen is 1, so we get 17,6 mole of hydrogen. Right. Now do the ratio, and the ratio is, they've given it to me, nitrogen first, hydrogen second. So the ratio 5,88 to 17,6. Next step, divide by the simplest number. Simplify the ratio by dividing by the smallest number. Now in this case, the 5,88 is the smallest, so I have to divide both of them by 5,88. So I get 1, 2. Now 17,6 divided by 5,88 is exactly 3. So I can finalize my formula by saying that the empirical formula is NH3. And we know NH3 as ammonia. Right. Next example. This time we have sodium, sulfur, and oxygen. It's given as percentages. So step 1, assume a 100-gram sample. Right. So if I have a 100-gram sample, therefore I have 32,4 gram of sodium, 22,5 grams of sulfur, and 45,1 gram of oxygen if my original sample was 100 gram. My next step is to go and convert this to number of moles. So for the sodium, number of moles is mass over molar mass. 32,4 divided by, now sodium has a molar mass of 23, and 32,4 divided by 23 is 1,41. Right. My sulfur is the number of moles of sulfur is equal to mass over molar mass. And I get 22,5 divided by 32. And 22,5 divided by 32 is 0,07. For the oxygen, same thing. 45,1. The molar mass of oxygen, 16. And 45,1 divided by 16, 2,82 mole. Right, now do the ratio. What was my original? Na to S to O. So 1,41 to 0,7 to 2,82. Divide by the smallest value, which is 0,7. But what I do with 1, I have to do with all of them. So 1,4 divided by 0,7 is 2. This is 1. And 2,82 divided by 0,7, 2.82 divided by 0.7 gives me a value of 4,01. So round it off, give me 4. So therefore, my empirical formula is 2 sodiums, 1 sulfur, and 4 oxygens. And we are familiar with this formula. That is the formula of sodium sulfate. Right. The last little bit of this is then my molecular formula. Now, what is a molecular formula? It indicates the actual ratio of the atoms in a molecule or a compound, right? So it's not the simplest ratio anymore, it is the actual ratio of it. An example that we can think of here is my hydrogen peroxide, right? Is that the simplest ratio? No, it's not. Right, because this can simplify to HO. So that one will then be my empirical formula, and this is my molecular formula, my simplest ratio and my actual ratio. Now there's also steps that you have to follow in order to do this one. The first one is find the empirical formula. So all the steps that we've done for empirical formula now will be applicable there. Then we go and calculate that empirical formula's molar mass. Normally in these, they give me the molecular mass of the compound I have, and I divide it by the empirical formula, and I multiply by the ratio in order to get that. So the first one that I'm going to do as an example for you is this one. So this should now be part of the document that you have in your drive. A chemical compound used in photography developing fluid indicates a chemical composition of 60.45% carbon and 5.48% hydrogen and 29.08% oxygen. The molar mass is found to be 110 grams, and we have to go and calculate the molecular formula. Right, percentages was given, so what's the first step? Assume a 100-gram sample. So therefore we have 65.45 grams of carbon, 5.48 grams of hydrogen, and 29.08 grams of oxygen. If I have mass, I have to convert to number of moles, so mass over molar mass. For carbon, 65.45 divided by 12. For hydrogen, number of moles is mass over molar mass, which is 5.48 divided by 1. Oh, that one I know quickly. Right, mole. And number of moles is mass over molar mass, 29.08 divided by 16, and we need to go and calculate that, so quickly do that. 65.45 divided by 12 equals, so this one works out to be 5.45 mole. Oh wow, very close now. 29.08 divided by 16 is 1.8 mole. Ratio, so it is carbon to hydrogen to oxygen. 5.45, 5.48, 1.8. So the simplest one here, smallest one, 5.45, 5.45. Sorry, I made a mistake. It's actually 1.8 is the smallest now. That was a bit silly. Right, so 5.48 divided by 1.8 equals 3. I'm sure this one will also work out to be 3. Indeed, and 1. So my empirical formula, C3H3O. Right, now we need to know get the molar mass of this. Molar mass of C3H3O is 3 times 12 plus 3 times 1 plus 16, which add up to 3 times 12, 55. Right. So now to go and find the molecular formula, I'm going to use this molar mass. I'm going to move here. So my molar mass is going to be 110 over the 55, which gives me a ratio of 2. So my molecular formula is C6H6O2. Right, straightforward. Second one. A compound was found to contain 49,98 carbon and 10,47 grams of hydrogen. The mass of the compound is 58,12 grams per mole. Determine the molecular formula. Right, now what do I see in this one first of all? Percentages was not given, masses. So I'm not going to assume anything. I'm going to straight away go into carbon and hydrogen. So for the carbon, number of moles is mass over molar mass. What number of moles do I have? 49,98 divided by 12. So 49,98 divided by 12 gives me 4,165. And the hydrogen number of moles is mass over molar mass. 10,47 divided by 1 is 10,47. Now this time I'm going to pay better attention. C2H, 4,165 and 10,47. So which one is the smallest? This one. So it works out to be 1, 2, and 10.47 divided by 4.16 gives me a value of 2,5. Right. Now when I get 2,5, to get the empirical formula now, I cannot round this up or down. So what I need to do is I have to multiply everything by 2. Right, so let's use this red one. I have to multiply the whole ratio by 2 to get it as whole number. So that makes it 2 to 5. Right. So my empirical formula is going to be C2H5. Right. But and now we're going to calculate what is the molar mass of C2H5. So that is 2 times 12 plus 5, which is 24 plus 5, which is 29. Right, gram per mole. So for my molecular formula, I'm going to use the 58,12 divided by 29. So 58, divided by 29 equals exactly 2, or rounded off 2. So therefore my molecular formula is C4H10. Great. Last one. Glycerol is a thick liquid obtained as a byproduct of the manufacturing of soap. Its composition is that amount of carbon, hydrogen, and oxygen. Percentages is given, and there I have a molecular mass. and we are going to use our assume 100 gram. Once we assumed the 100 gram sample, I'm going to have that I've got 39,12 gram of carbon, 8,75 grams of hydrogen, and 52,12 gram of oxygen. My next step is convert to number of moles. Now I'm going to simplify it this time a little bit. I'm just going to use it for each of them. So that is 39,12 divided by 12. This one is 8,75 divided by 1. And 52,12 divided by 16. So I've already have it in my ratio. 39.12 divided by 12 is 3,26. My hydrogen 8,75, and my oxygen 52.12 divided by 16 equals 3,25, 3,26 rounded off. Smallest value 3,26, 3,26, 3,26. So 1 to 1, and the middle one 8.75 divided by 3.26, and we get a value of 2,68. Right. Now, is there a way that I can get this a whole number, 2,67? Yes, I can. By multiplying that by 3, I get this to be 8. So I'm going to multiply everything by 3, and that is 3, 8, and 3. So my glycerol's empirical formula C3H8O3, which has a molar mass of 3 times 12 plus 8 plus 3 times 16 of 92 gram per mole. So what is my, what can I see? My empirical formula is the same as my molecular formula because the masses are exactly the same. Right, thank you for listening. What you need to go and look now is that you can do Activity 1, page 181, questions 1 to 7. Please refer to the answers that's going to be on the communicator or on the Google Drive for you. Thank you, grade 11s. See you soon.